we're looking at this non-specific information. Okay, and since non-specific is going to be the same every time, okay, because the third line of defense, we get specific. And when we say specific, we're meaning specific, okay, which we're going to get to. In non-specificity, okay, in the resistance that we're going to have, this means something has breached my first line of defense. Okay, something has breached the skin or the mucous membranes, and now the body needs to attack it. So, when we encounter a pathogen, anything that's not part of our body, okay, if it gets past that first line of defense, those external barriers, it's going to get attacked. It's going to get attacked the same way, okay? These pathogens, basically the leukocytes and macrophages are going to play a huge role in attacking that pathogen. The types that will be involved. Now, the reason I say think back to Chapter 18, when we think about our bone marrow and how it gives rise to blood cells. Note my terminology. I'm giving rise to the red blood cells, white blood cells, platelets. Do you remember how they were separated out in groups because we've got the one huge stem cell that gives rise to colony factors, those colonies that will give rise to red blood cells, all those white blood cells, leukocytes, monocytes, okay? So, neutrophils. And if you go back and look at all your colonies, you'll see the line that they're going to come from. They are very important. They get to wander around. What this means, they get to move from the bloodstream into my connective tissues of the body. And they will simply get to wander around. The way that they function, phagocytosis. Now, there's also a video for phagocytosis. All that is this cell, as it wanders around, okay, basically it's this really cool motion that it makes, and if it encounters something foreign, it simply engulfs it. It takes it in. The lysosomes that are present, and everybody remembers lysosomes? To lyse, meaning break something up, okay? The lysosomes destroy whatever it was that was foreign. They have digested that foreign material. And they will do that for their lifespan, or until they cannot handle the amount of the foreign material. If the foreign material becomes too numerous, we're going to have to get specific. But under everyday circumstances, under normal circumstances, this is occurring all the time. Neutrophils have a certain lifespan in our body. They'll do their job. We'll produce more. The other ones will get, they'll undergo apoptosis, and lysosomes will take care of all the stuff inside of them. All right? Another thing that these cells can do they can produce a, oops, that should say cloud, sorry, typo, a cloud of bactericidal chemicals. Meaning, it's like a little poof. They can literally poof out these chemicals into tissue fluid. Now, you remember, because I keep drawing this, because for some reason we keep coming back to this. Anybody know what that reason might be? Where does everything happen? At the cellular level. So if I'm in my tissue with my cells, where I've had my blood supply, I have around it my extracellular fluid, and what did I say that neutrophil could do to get to the level of these cells? If I have my capillary bed, arterial side, venous side, this is a cell that is produced in the bone marrow, meaning it makes it to the bloodstream. And what did I say it could do to get, because it has to be able to get into connective tissue. Does it stay in the blood vessel? No, it has to move out. So this cell actually gets to move out of the bloodstream, and it gets to wander around. If it encounters anything, that's where this cell will engulf it, eat it, digest it, and take care of it. And now, hopefully, whatever that pathogen was is taken care of. So if I have some little pathogens that might be in my extracellular fluid, but I've got some neutrophils wandering around, hopefully they can engulf it and digest it. But something else they can also do is they can poof out, squirt out, whatever term you want to use, these little bactericidal chemicals. Now, what does that work against? Bactericidal. Bacteria. Viruses, they will tend to engulf. So, as long as those neutrophils, okay, can wander around, do their job, any of these like pathogens that are in there, hopefully they're being taken care of, which is done on a daily basis all the time. So, if we need to, and there's a little more than maybe the cell could, like deal with, that chemical release, that bactericidal chemicals that get released, they act like a super oxide. What do you think of? From the periodic table, what does super oxide make you think about?
Oxygen.
Oxygen. Now, let me think about that for a second. Superoxide, hydrogen peroxide. Anybody know the chemical formula for hydrogen peroxide?
H2O2.
H2O2, which will give another oxygen. Hold up. Superoxide. Now I got another oxygen. And then hypochlorite. Anything come to mind? Chloride, chlorine, which in the body does that. It's making good old oxygen, but now wait a minute. Why oxygen? Under normal conditions, we tend to see oxygen written everywhere as O2 because it exists as a diatomic molecule. That means out here around us, for it to be stable, it will connect very readily to another oxygen. But you get it in the body where it can be under these circumstances, we'll end up with one. Now, is that always a good thing? Not necessarily, because what does that end up creating? It ends up creating a free radical. Ever heard of that? Come on now. Free radical? I see one person shaking their head. Two. That's it? Three. What are they? Any idea what they are? How have you heard about them? All right, you've heard about them in chemistry. Anywhere else? Oh, come. Yes, 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 you have. You'll pay attention to it now. Commercials for beauty products. Commercials for vitamins. Commercials for health foods. Oh, this is going to fight the effects of free radicals. Okay. Well, yeah. What's the effect? Okay, free radicals. In a case like this, they could be beneficial because what they do not have their full outer ring of electrons, and therefore they are very active. And when they're very active, they bump into stuff. But they don't just bump into stuff, they bump into it enough to break it apart. So under a situation like this, where I may need a pathogen to break apart, it'll do that, and that'll be good. But under other conditions, it's destroying molecules that are healthy. That's why you hear products kind of get advertised to us as fighting the effects of free radicals. And the goal is to be providing something that the free radical can attach to and not be breaking up good molecules. In times where the body is needing defense, it will work in a way to like burst up the bad pathogen. So this would be non-specific. It's not working against only one type of, say, virus or bacteria. It'll work against all of them because it sees it as a foreign cell and it wants to break it up. So this would still be non-specific. Our eosinophils, love these little guys, okay? These cells, they are found a lot in our mucous membrane.